Hello and welcome to Chemspec Digital. My name is Christiana, I'm event manager, and I have the pleasure to introduce the first presentation in the RSC Lecture Theatre. However, before I do, I would like to point out that we are recording this presentation to make it available for everybody to view on demand. Attendees are also invited to add questions into the chat function on their screen, from where we will read them out at the end. And now I will hand over to Etienne Baco of Mesta. He will be presenting Continuous Flow Chemistry is not a dream, but just a tool in the fine chemistry industrial toolbox.
Hello, thanks Christian for the little introduction. Thanks to everybody for joining this session. Thanks to Chemspec and RSC to give me the opportunity to present on to present a bit of work made at Mesta for years now about continuous flow chemistry. So I'm very glad to present you what we are able to do now. And for many years, we are thinking that continuous flow chemistry is a dream, is really a solution, a universal solution, but it's not a dream for us as in fine chemistry, just an industrial toolbox, which is very interesting for a lot of reasons, and we're going to present you. To better understand, so okay, sorry, I tried to get you with the presentation. I think it's okay now. I do not. Okay, so you can. It means you can see me. Okay, it's good. So before to know how we manage to how we brought flow chemistry at Mesta, we need to know who we are, history. So in 1971, Mesta is founded by two pharmacists, and at that point we are just let's say a normal private company dedicated to pharma markets. And after that, we've been part of different big groups in fine chemistry, and from that time, we learned a lot about quality, different markets, because we've been held by a different owner, but we were still subsidiary company, the fine chemistry part of this big group. And in the beginning of year 2000, we've been bought by a different group in a very with a different outlook of what is fine chemistry. And in 2013, also, we've been bought by Ariel Group. It was very different because from a subsidiary company, we have been bought by people who had a long-term vision with an idea of innovation and the need to make an enterprise to see further than just to just a financial way of making chemistry. So now, thanks to that, with this AT group and Ariel group, we found a way to work to make something different thanks to the innovation. And we are now 85 people, and with some interesting results. We sell to we are exporting 70% of our sales. we are able to serve different markets, even if we come from pharma. We develop some very high quality standards as we can make for we can make we can work GMP. We can use we are FSCC 2000, which is very useful and mandatory for food or aroma markets, and we are dedicated to technology. So to understand the flow chemistry as La Mesta, you need to understand the U-turn happening in the year 2000. So coming from, let's say, financial group, we were a little entity, we part of a big group. And then at that moment, we became a very, let's say, we became a company with a long-term vision. This U-turn is also a strategic shift, because when La Mesta is bought by IT Group in the beginning of year 2000, the situation was not so, so comfortable for La Mesta. All the products were leaving to Asia for many reasons. The chemistry, industrial chemistry had a very bad reputation. So it was very important. Let's say the waste made by industrial chemistry was a problem. Nobody wants chemistry near its site. And also for La Mesta, the other problem, as you can see, the picture of our site, you have mountains, you have river, we cannot extend. So the question was the strategic thinking, the vision we had was to, okay, how can we keep to make industrial chemistry? Because we are not a very industrial area on French Riviera, because it's more known for the seas, the mountains, the tourism, but not so much for chemical plants. So how we can be accepted by the people all around, and all of that without expanding the site. Okay, so in other words, the question was in 2000, how to still be here in 2020? How can we make something different to still be here? And we can see we are in 2021, so we brought the good answers to that because we're still here. So our needs, finally, we established the needs we have to still be here. It was the miniaturization, as we cannot expand, the safety, to be accepted by everyone, and to make something, to be able to take some chemistry. It was to masterize the safety, the need to innovation, to make something different, not better, not worse than other, but something different, to have an opportunity to get a product other cannot do. And productivity, but productivity in order to gain some space, some capacity, some capacities, not to produce more or less expensive. It's not productivity on an economical point of view. And our asset at this moment was the marriage between engineer and industrial chemist, meaning that from engineering services and custom synthesis, we can bring a lot of we can try to find a new tool to different of what was existing at that point. And the answer was finally the continuous flow chemistry. And so you can see here on the picture, we have a long tube with a steering engine in order to make chemistry inside. It was in 2004. It was coming from the strategic vision. If we are coming back to the 2000s, at that time, when we presented our business to a business model or assets to customers, the idea was to get your product, to use our engineering services, and so our knowledge in chemistry, continuous flow chemistry, new technology development, and our knowledge in custom synthesis, synthesis optimization, and process development. So all that together what it allowed us to take your process, product for you or product by you, bringing to the customer a tool, again, a tool to produce. From that, we just keep La Mesta because AT Group, we change our owner. We kept the custom synthesis, the synthesis optimization, the process development, the industrialization, but we are only producing for our customer, and we are not bringing the technology. We are not bringing the technology to the customer. We are keeping for us, but we are bringing the product. So RAPTOR was born. So the continuous flow chemistry at La Mesta is a RAPTOR, is a device you can see here. So a quick presentation of the characteristic. In red, you can see every single characteristics of what we can do in this specific device. We have a volume inferior at 1 liter. We can steer very strongly. It's a very important heat and material transfer, a good exchange area for exothermic reaction. We can work up to 500 liters per hour, meaning that we can make a lot of reaction. We can manage a residence time between 7 seconds and 1 minute. So it's a wide range of possibilities. Again, for the temperature, we have a wide range of temperature. We can work at very high pressure, and we have an hostile equipment, meaning that we can use very corrosive needle. And on the other side is not some technical characteristics, but more some a philosophy of what can be done with our RAPTOR technology. So this is a proprietary technology, so it's not patented, but it's only on our site. It's very versatile, meaning that we can use gas, liquid phase, liquid, liquid solid, and also the gas, liquid, and solid at the same time. We can work GMP, we can work FSSC 2000, so it's totally compatible with that. Important is also the generation and the introduction of solid, meaning that we can work with suspension and we can generate some salts, for example, and it can be managed by this type of continuous flow chemistry equipment. We have multiple entries, you can see here, meaning that we can have a lot of different possibilities to make some reaction, to make some chemistry inside. So, and we can also prepare and work up and make the work up also in continuous flow. And thanks to that, we have dedicated a workshop, meaning that all the product will be brought to that device. And in the same, let's say, on the same manner, we also have a phosgenation workshop, which is able to generate phosgene here and to bring it to a RAPTOR, so a continuous flow chemistry device, to make the reaction and then send it here to the different vessels. So here are all the, let's say, what we can make in a continuous flow reactor. To see here, you can see the evolution of our PILOTE industrial projects. So from 2004, where is born here the RAPTOR, we have now tried between, let's say, discuss or made some lab trials between 15 and 60 projects, and on this so at lab scale, but at PILOTE and industrial scale, we got more and more, and we have now 11, 12 this year, with this year industrial production thanks to this device. So here are some different steps, different reaction we have been able to make with this device. Here you can see evolution of the different workshop. And to better understand, okay, here you can see we made some different reaction, but we need to link that to the fact that at the beginning it was almost lab trials or a few quantities, but thanks to different projects, and here you can see the different turnover stemming from continuous flow by year. The first 10 years was not disappointing, but it was, you can see, between 500 kilo euros and 0 kilo euro per year. So it's very, very, very long, let's say, long time to get the technology, let's say, profitable, as you can see. So the first 10 years was almost the discovery, the setup, to find the good way to use this tool. And thanks to different projects, we managed to make money, more and more money, with carbonylation, for example, was a good example. And in 2015, the hydrolysis decarboxylation, I will show you after, led to 2.5 million euro turnover, meaning that now we can invest in more and more in this technology, and bringing us to a dedicated workshop in 2017. So meaning that this tool became more and more useful and present into our plant. And also, thanks to this turnover we made from 2015, we can make a dedicated phosphonator workshop. So just to show that it took time to develop such a tool, such an interesting tool, to get, let's say, not just profitability, but a substantial turnover. It took 10 years. So how did we use this let's say this tool? At the very beginning, you can see here in the picture that the continuous flow reactor was between, let's say, two classical vessels. So we were bringing it to the plant. And why we use that in place of a batch chemistry, classical batch chemistry? It depends. The use of the flow chemistry tool is very depending of the challenge you are facing, of a specific product or a specific chemistry. Here, it was carbonylation, launched in 2009. The challenge was various. The safety, because we were using CO2. We need pressure. We were using triphilic acid, which needs to use, which is very corrosive. So it means alloy reactor. So if we wanted to make it in batch, it means a very large vessel of 6 cubic meters or maybe less to work under pressure of 40 bars, all in alloy. So meaning a large amount of money, a huge investment to be able to make such a reaction in batch. So inputs or answer from the continuous flow of the specific tool was the fact that you can stir very well. You are in alloy. You can handle the thermic transfer, so it's perfect. You also have possibility to work under very high pressure, so no problem to make it in this tube, and a very tiny volume. So a perfect management of the reaction. Also because we are using gas gas liquid chemistry. It can be done also in our tool, multiple entries, meaning that we can handle, and under GMP because it was a pharmaceutical market. So thanks to all of that, finally the continuous flow chemistry was really the perfect tool, was the answer to all that problematics we had with such a reaction. So after different trials, after launch in 2009, we have, as I said, the skid here that you can put in the plant. And in 2019, again, as the project and our knowledge advanced in that technology, we could improve all the line to make this chemistry possible. So we improved our tool thanks to our knowledge. So you can see here that we can warm before going to the RAPTOR technology, and we dedicated some lines in Asteloid to be able to make it directly in that dedicated workshop. So it's really in 10 years way to get from that box in the plant to have a really dedicated workshop to make such reaction. And just to give you an idea of the way we made in batch, for example, it was impossible, as I said, in the existing equipment of La Mesta. But thanks to the first trials with the first RAPTOR and the second RAPTOR, we were able to gain in productivity. So we earned sometimes to make other things in our plant. We keep good yields, and we improve we improve our productivity of our campaign. So it's perfect example of what can be done with this specific tool. Another very interesting example, again, a lot of challenges in this synthesis. It was we've been asked to hydrolyze and decarboxylate an isocyanate, which is problematic for safety reason because CSI hydrolysis give a large amount of CO2, which is not so nice for all workers, and a very strong exothermy which has to be handled. So again, the RAPTOR, this tool has been brought some inputs, some answers to that challenge, to these challenges. Again, the versatility, because we can use liquid gas phases. It's in Asteloid. We can make in a dedicated workshop, so very easy to handle. And the preparation and workup in continuous also can be done. And also the always specific steering, which is a very important asset for this kind of reaction. So other inputs, very important, was the fact that this in the past this reaction was made in batch, but the use of CSI was not so easy. And thanks to the chemistry, the flow chemistry, we can use some containers. Also, we gain in quality with a better control of the reaction, and there is a very large complementarity between the batch chemistry, because this single step is part of a five steps reaction. So it allows us finally to have a better yields. So in 2015, when we start the project to pass from the batch through the RAPTOR, you had here the RAPTOR device to make the reaction here. And then it was also the opportunity to make it in the dedicated workshop. So in 2017, when we built this specific workshop for the RAPTOR here, we've been able to improve again the venting, which is the very critical part. It was possible only in continuous. So to get here a venting in continuous, meaning that compared to the batch reaction, the generation of CO2 was uncontrolled. We really need to have a temperature behind 15 degrees to avoid any problem with the generation of CO2. And thanks to RAPTOR, and the venting device for the RAPTOR 5 here, when we got in the specific, let's say, dedicated workshop, we were able to know exactly how much CO2 we were generating per hour. So a better control of the generation. It's so for, and on a safety point of view, very easy. So here, and the other point was the gas was venting in continuous, and the formed intermediate was packaged directly. So from 1 week in batch with a problem of safety for the same campaign of 2 metric tons, we went from 1 week to half a week. So again, it allows us to use this time and use this batch differently. So to gain, not in productivity on an economical point of view, but on capacities to make some other product in the same time. And another difference is the quality. From a 75% quality by HPLC, we were more around 85–90%. So once the device properly set up, it was very easy to get good quality. And the methylation is also is a third and last example I can share with you to see how this tool can be very useful and complementary to the batch. It was also a reaction made in batch for years and years, but it was a very low value product with volume increasing, and we wanted to keep some, let's say, some capacities to make something else. And also the reactant was a bit unsafe. The CMS is not so easy to handle. So the idea was to take the opportunity of an existing product with a, let's say, important turnover, to take the opportunity to build the dedicated workshop. So the dedicated workshop was made for this specific product. So we added the remote control in 2017, and also, so you can see here the remote control. So everything is handling by a computer, and also our will was also to be able to not only to make the reaction, but also to bring the workup in continuous, which is, let's say, the step further we wanted to work with. And it's why here you can see the RAPTOR here, and the reaction is made in the device, and then the biphasic reaction is in this big vessel, and continuously discard water phase from one side and toluene phase to another vessel to be treated. And you can see here the continuous phase separation. So this project gave us the opportunity to build a really new tool, so this dedicated workshop, and with the ability to use fast separation in continuous. And all that has been, let's say, tailor-made only for us. And thanks to that, we've been able to, for annual production of 60 tons, we gain in waste, in quality, in productivity. And so we we're able to gain some capacities. So these three examples show how how we develop such a tool, and how we can use such a tool, and also how we can improve such a tool thanks to the different challenges we have on any single projects brought by our customers. So to conclude on that tool, on that continuous flow chemistry at La Mesta, and in general, we can see that at La Mesta it has been very useful. We saw the turnover; it represents 23 millions since 2007, and the first industrial production, and 300 tons of products issued from this tool. And also for our operators, for our operative, it's a routine tool which can be used in 3 shifts. So very useful. It's not one popular belief. It's an ultimate tool that everything can be made in continuous. It's the answer to everything, but and you can gain in productivity and be everything is perfect with continuous flow. For us, it is not. With 15 years background, the aim of the continuous flow is not productivity. You can gain in capacity because you have a very versatile tools you can use in place of batch for several reactions, but you will not gain enough in productivity on an economical point of view, because the setup is really important. And we have a very versatile tool, meaning also that we cannot dedicate it to one product. We have several products coming from that. So it's why it's something it's a popular belief. It is important to be one of. The device alone is nothing when we're talking about flow chemistry, because it implies a very strong engineering skill, and also very know-how and knowledge of the existing capacity to really well integrate all of that to make it to make some specific and innovative chemistry possible. It's not a universal solution. Also, it's very important to have that in mind, that the all-in continuous is an illusion. You can work, and we've been working for 15 years to have more and more abilities to make all-in continuous when it does worth it. And but all-in continuous is very, very difficult. Also, something very important to know is that continuous flow is a very demanding tool, meaning that the industrialization has to answer a challenge that I tried to show you through the different example I took. It can be safety, quality, the impossibility to invest. You can also work, it can be an answer also for carbon footprint point of view, but it means it has to bring something. It needs to be an answer. It's because the development will be long, so you need to have a very long-term vision on that answer of the flow chemistry. The good point is that even if the development is longer, it is easy to scale up, because from our experience, when you have the good setup at little scale, you can really easily scale up on our bigger RAPTORs. And as you understood, each project is an opportunity to improve, meaning that when you have a project coming, you can adapt your not only your batch chemistry, but you can also improve your continuous flow chemistry in, let's say, more workup, more preparation, continuous. So each project is really an opportunity improvement. It's really something important. And last but not least, when we are talking about continuous flow, it's often seen as the perfect answer to everything of productivity and so and so. But as we saw, those first 10 years were really not difficult, but it was really uncertain. And so you really need to have a long-term outlook to think about continuous flow. So again, to conclude, it's really useful tool, but it's just a tool. It won't be the answer to everything, but it will allow you, or it allow us to make something different. So if you need, if you need to discuss, if you have some project, if you see some opportunities for your chemistry or from our knowledge you want to share or exchange about our technology or what we can do for you or with you, please do not hesitate to contact us, to contact me, Etienne Baco from Mesta, and we would be very, very pleased to exchange with you. So I thank again everyone for attention. If you have any question, I would be very, very pleased to answer to them. Thanks a lot.
Thank you, Etienne. That was very good. I would have just double checked. I don't think, as far as I know, there have been any questions from the audience thus far. We might just have a time for one if there is. I might just wait while somebody is busy typing. Otherwise, as Etienne said, Mesta is on the digital platform, and we do invite you to make contact with them and to still arrange some meetings, either for the rest of the day or tomorrow. Etienne, you're on the platform yourself, and you've got some colleagues there as well, so there is some availability to connect with you.
Yes. I have a few meetings planned, but there are still a bit of availability. So at your disposition to, if you have any question, any clarification you may need about our technology, or you see something, it will be very, very nice to talk with you.
Brilliant. Thank you, everybody. This marks the end of this session. And thank you very much to Etienne for taking the time. And as I said, reach out to Mesta on the platform. And thank you for all attendees for watching. Goodbye.
Goodbye.